So welcome everyone to Our Lady's Room. Please feel free to say hello in the chat. Where you from? Nice to have people from Washington, D.C., Congo. Hello, everyone. We give people a bit more time to log in. Hello from the Philippines, Virginia, Madrid, Lisbona, Portugal, Budapest. As usual, we do a little introduction of our chapter, very briefly, just for those of you who doesn't know about us, what we do it for. People from Chile, Turkey, the UK, Argentina, Poland. You are all very welcome. Thank you for joining us today. Orlando, Nigeria. We are going to record this meeting, as you see, and post on our YouTube channel. So please feel free to follow us on our YouTube channel. That will help us a lot. Okay, we are already nice number. So I think we can get started. So welcome everyone to Our Lady's Room. This is our March event, and we are a chapter promoting, mentoring, networking, and provide expert upskilling in the R community. Today we are going to talk about dplyr 1.2, and it will be a practical session with our speaker, Isabella Velásquez. A bit about us. We have a global mission for lifelong learning. Our mission is dedicated to promoting diversity within the R programming language and the environment. We focus strictly on cultivating safe, collaborative, and inclusive learning environments. And the scale, we are an active network comprising of over 250 individual groups across the globe. Our Ladies Room, a growing ecosystem. We host regular monitoring events, in virtual and in-person format. And our focus is dedicated to practical real-world data science and advanced statistical tools. Founded in 2022, we are proudly collaborating with other local Our Ladies chapters, Our Ladies New York, Paris, and so many others. We are in a community focused on building skills and connections. So our technical upskilling focus is to hosting hands-on talks, tutorials to cover essential data workflows, such as in this case. Today we are going to talk about the dplyr, but we also love to talk about Git, GitHub, and many other things. We do not deny that we also investigate other languages as well. So we like to build a community, as I said, for networking, mentoring, for career support, a gym platform where you can practice your while sharing your projects and things. Sometimes we host, as today, experts, which are providing demos of the latest from the R community. So we are open source advocates and part of the free software movement. As I said, this is a safe space for learning, and it is free of charge. If you are a beginner, it's very good for you to find tutorial, a new workshop for you to learn a bit more, and expertise. If you are an expert, you always find something that you might not know. So stay tuned. Here is our website. This is the QR code of our website. Please have a look at it. You'll find blog posts with the latest events, recordings, and all the other things at ourladiesroom.org. This is all for today. Thank you very much. Without further ado, I'll pass the word to Isabella Velásquez. She is a developer relation at Posit PBC expert at the intersection of programming, communication, and data science, passionate open source advocate. Thank you, Isabella.
Thank you so much. Thank you, everybody, for being here. Let me share my screen. All right, Can you see it okay? Awesome. Well, thank you all so much for joining us today. We're going to be talking about one of the really powerful tools from the Tidyverse called dplyr and the latest release, which just came out a little while ago, 1.2.0. Thank you, Federica, for the introduction. Just to briefly recap, hi, I'm Isabella Velásquez. I really appreciate the opportunity from Our Lady's Room and Federica for being here because I am very excited to talk about this new update to the dplyr package. And as Federica mentioned, I'm on the developer relations team at Posit, which is formerly known as our studio. I have been using R and the Tidyverse for many years now, and I really think the functions that we're going to see today are truly exquisite. And so I really hope that you learn from this presentation and are inspired to add them to your workflow. In terms of just a little bit of housekeeping, the slides are available at this link. I can reshare them in the chat as well. And I'll be mentioning various links throughout the presentation. They're all available at the end of the slide deck for future reference as well. And so if you're lost, you're trying to remember where are the slides again, they're also linked on most of the footers at the bottom of each slide. Really briefly, I want to talk about and introduce today's data. So we're going to be taking a look at data from the Tidy Tuesday project. And so if you've never heard of Tidy Tuesday, it is a weekly project where a data set is curated, cleaned up, and shared with the community. And everybody is invited to take a look at it, work with it, practice their skills, and then visualize it in, very creative and amazing ways. If you ever want some inspiration, take a look through Blue Sky or LinkedIn at the really amazing visualizations that people create with these data sets every single week. And so when preparing this presentation, I was thinking that, might as well use this opportunity to also highlight this week's Tidy Tuesday data. And so the data set is salmonid mortality data from the Norwegian Veterinary Institute. This week, there are actually two data sets within the repo, but we're just going to be taking a look at one. And this data is from 2020. In terms of what the data actually looks like, it's going to be shared or saved in an object called monthly losses data. And if we read in that CSV and take a look at the first few rows, you'll notice that there are these 9 columns that cover things like species, date, geogroup, which can be area or county, region, which is the name of that geogroup, losses, and then a variety of variables that describe how those losses happened. And so just a really nice data set to practice some of the functions that we're going to be taking a look at later. But first, I want to introduce and focus on dplyr, which is the main package that we're going to be talking about today. And so if you are new to R and you haven't heard of what a package is, it's a collection of functions. And what functions allowed you to do is do repeatable actions that you can perform on your data. And dplyr is a core member of the Tidyverse, which is a curated collection of R packages specifically for data science. And so all the Tidyverse packages share this opinionated philosophy that data should be in what's called a tidy format. And so tidy data means that each variable is a column, each observation is a row, each value is a cell. And we're working with Tidy Tuesday data, which very kindly by the curators has already been tidied up so we can just jump into using these Tidyverse packages. And because all of these tidyverse packages share the same grammar and design, they're meant to really work together and make data analysis very efficient and easier for us, and also more readable. We're going to take a look at some of the verbs, and we can kind of understand exactly what is happening just by reading the code. And so we'll just be focusing on dplyr today, but just know there is a whole ecosystem of different packages that you can use together in conjunction with dplyr. And so, according to the official documentation, dplyr is a grammar of data manipulation, providing a consistent set of verbs that help you solve the most common data manipulation challenges. So you think when you open up a data set, what are probably some of the first things that you're going to do? Uh, dplyr is a great tool for you to reach out to when you're starting off. So let's go through some of the really fundamental functions of dplyr just so we can get a sense of what they look like and how they are structured in our code. So first, let's look at a range. So I mentioned earlier, one of the ideas behind the tidyverse is that code is readable and understandable. So if you think of a range changes the ordering of rows. And so unlike other functions, which might actually change the content of your data, a range only changes the order in which you see it. And so in this example, I generated these images using this very cool tool called Tidy Data Tutor. So we have a data set on the left, and if you take a look at the date column, it is out of order. We have October 2023, and then October, or then January 2023, and then January, and then June 2024. So it's all over the place. So let's say I would like it to be a range from the earliest date first to the last date last. We could take our data set and then use what's called a pipe, and then put the verb, arrange, and then specify which column we want to arrange, in this case, date. And then we get the data set on the right. So now date is ordered according to the dates in a way that makes more sense. And previously I mentioned dplyr is a grammar. And so this kind of like syntax in terms of taking your data frame, using a pipe, using a verb, and then specifying the columns, that's like the general syntax that we'll see throughout this presentation. So another example of a dplyr verb is select, which picks variables based on their name. And so this allows you to subset columns to only the ones that matter to you for your current analysis. And you can imagine this is very helpful if you have like dozens and dozens of columns, or in my case for this presentation, you only have a little bit of screen space in order to show an example. So for here, you'll notice that within select, I've supplied not just one name, but multiple names separated by columns that define which are the columns that I want to keep. And so in this case, species, I know they're kind of morbid names because it happens to be about fish death, I'm sorry, dead, discarded, escaped, and other. And so then we get the data set on the right, which only has kept those columns that I'm interested in. And I'm happy to stop at each spot to see if there are any questions, but I'll just keep working through until we get to, a natural pause point.
We have someone who raised his hand. Daniel, please, can you unmute yourself?
I think I see the question, can a range work on multiple columns at a time? And yes, you can specify multiple columns like in this select example. And I believe it works from left to right, and so it might override each other. There is another function called group by that we'll see in a little bit that might help you if you want to arrange, say, the date first, and then the region, and then the numbers within losses and things like that. So that would be my recommendation. The next verb that I wanted to cover is summarize, which it's going to create a new data frame by collapsing multiple rows into a single summary. And so if you work with a lot of data, you are often wanting to calculate summary statistics like averages or the maximum or the minimum of a particular column. And so that is what summarize allows you to do. So you take a column of values and turn it into a single value. And then you can also create a new column that contains this value or like a new name for that column as well. So in this example, I've taken the monthly losses data, I typed it and then it put summarize. And in this case, I'm saying create a new column called mean losses, which is calculated by taking the average of the losses column. So all those values in the losses column are added up, divided by the number of them, and then output in this new column called mean losses. And you'll see we no longer have 4 rows of data, we only have one. But one thing that makes dplyr extremely powerful, which I just mentioned, is this idea of group by. So any operation in dplyr can be done by group. And so what this does is it won't look like anything has changed. It takes this data frame, it converts it into a group data frame, and under the hood, these like new buckets or partitions are created based on the values in a particular column or more than one column. And then you can use group by as a setup for other verbs like summarize. So in this example, take monthly losses data, and then we group by the region. In this case, we only have 2 regions, region 1 and region 2. And so all of the region 1 become one bucket, all of region 2 becomes a second bucket. And then I take that newly grouped by data frame and pipe it into summarize, which, if you recall earlier, collapses things according to whatever function that you want to run on it. In this case, it's average, but instead of just giving me a single row as output, now I get 2 rows, one for each of the region buckets. And it also maintains that region column that unlike the earlier example, which only gave me one single column. So now I've taken, just to kind of briefly recap on the left, we have this like under the hood group by data frame, group by region, which each one is made up of 2 rows. And then because I'm saying calculate the average, for region 1, it adds up the losses and divides by 2. For region 2, it adds up the losses and divides by 2. And then it outputs that data frame on the right. So those are some really quick examples, but funnily enough, those are not the ones that we're going to be focusing on. Another really powerful dplyr function is called mutate. What mutate does, it adds new variables that are defined by other existing columns or a whole new variable as well. So you create a new column or modify existing ones, and it calculates a value for every single row in your data set based on the logic that you have provided. So you can use existing columns to calculate a new column. In this case, I'm saying take dead, discarded, escaped, and other, and for each row, sum that all up and put it in a new column called total. You can also create a whole new variable with mutate as well. And mutate is going to keep all of your original rows and columns. It won't remove anything. It'll just append your results to the right. There is another function called transmutate, I believe, that only gives you the columns that you have calculated. And within mutate, there is another function that we can use called case one that allows you to create variables based on multiple conditions. And so generally, this is used within mutate to categorize your data. And so, for example, here we have monthly losses data piped into mutate. What I'm saying is create a new column called loss rating which is defined by when losses is greater than 100,000, uh, rated as high, and when it is lower than 100,000, rated as low. And you'll notice the syntax here, it's very like particular. It uses this what's called a tilde syntax. Tilde is like the squiggly line. On the left-hand side is going to be your logical condition, and the right-hand side is the value to assign if that condition is true. And something important about mutate, it evaluates conditions from top to bottom. So once something has matched your logical statement, case one stops looking for it. So just a thing to be aware of. But this one, in this example, we take losses. If it's greater than 100,000, it creates a new column. Well, it creates a new column regardless, but for losses greater than 100,000, it's going to give it a rating of high, and then for lower than 100,000, a rating of low. And the last foundational, once I'm almost to the next part, so then we can hopefully ask some questions. The next foundational part of, or foundational function of dplyr is one called filter, which picks cases based on their value. So in this case, I'm saying take monthly losses data and filter for region equals 1. In that case, it only is going to keep the rows that satisfy your conditions. So if a row tests true, it stays. If it tests false or NA, it's dropped. So in this example, on the left, we have 10 regions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm saying filter region equals 1. And so my outputted data frame is only going to have a region equal to 1 left. And there are, like, we're just scratching the surface of what dplyr can do. There are dozens of really like other foundational functions and also really specialized functions available. But as I mentioned, for right now, let's just focus on filter and mutate and case when. Okay, happy to answer any questions that came up. I see one question is, will case when result in a factor automatically? No, not necessarily. You can use case when to create a new column of numerics, for example. Okay, so that was a brief overview of dplyr. Now let's go jump into dplyr 1.2.0. And I do want to mention everything that we'll cover today is explored in really great detail in this really fantastic post by Davis Vaughn, who is an author of dplyr. And I've linked it in the slides, and I really highly recommend you take a look at it if you haven't already. So Davis does a really great job explaining the underlying philosophy behind these updates with very clear and practical examples. And so a lot of the examples that you'll see today were built on the insights that he shared in his post. So definitely take a look. So let's start with a brand new feature in version 1.2.0, which is called filter out. And so if you've ever used the filter function before, you might have been where I've been in the past, staring at a line like filter region equals 1 and trying to remember, am I keeping region 1 or am I dropping or getting rid of region 1? Even when I was just like explaining what filter is, I'm like, oh yeah, it's keeping region 1. And so if you imagine that kind of ambiguity opens the door for errors, especially if you're like chaining a lot of pipes together. And so really the reality is that the original filter function was optimized for keeping rows. And often because it was, the quickest tool at our disposal or the only tool that we had, we may have forced it to drop rows using negative logic. So let's take an example. I have this small data set called monthly losses NA with species, region, and losses here. And so let's say my analysis asks if I could drop rows where the region is 3 and the losses are greater than 700,000. So take a brief look, try to identify the rows that you think um, should be dropped. Wait a few seconds. Okay, so taking a look, it's row 3. So in our small data set, according to drop rows where region is 3 and losses are greater than 700,000, that's the one we want to get rid of. And so you might write something like this. Using the traditional filter function, we would usually try to negate that logic. So we'd write a pipe that says, keep everything where it is not the case that region is 3 and losses is greater than 700,000. And that exclamation mark is that negation syntax. And so if we run that, we get this result. But if you may notice, our original data frame had 5 rows, and this one only has 3. So what happened? So our row that had an A on their losses was also dropped. And so I mentioned this really briefly at the beginning, but a filter is like looking for a definitive true to keep a row. If it hits an A, it doesn't know if the condition is met or not. So it plays it safe and drops that row. And in this case, that's not what we wanted. We only wanted to drop the rows that definitively match our criteria. And so because of that NA, we might have lost, a perfectly valid piece of our data set by accident. And so you can use filter to work around this. So to use the original filter for this task, we can't just say not this. We have to build a much more complex piece of logic. And so in this case, we have to explicitly design a negation that says, keep everything that doesn't match my criteria or anything that where region is NA. And similar with losses. You keep everything that that doesn't match my criteria or losses are not NA. And so that does give us the right response. But as you can imagine, it's really easy to forget those extra NAs or what you're doing, or if you revisit this a year from now and you're like, what was I doing again? And so this is exactly the kind of friction that dplyr 1.2.0 was designed to solve. So rather than trying to think through negations and logic and things like that, just remember, it's very clear. Use filter to keep rows, use filter out to drop rows. So if you recall, we wanted to drop rows where region is 3 and losses are greater than 700,000. And now reading out the code, that's exactly what it looks like. My data frame piped into filter out, region equals 3, and losses is greater than 700,000. It's like almost exactly matches how I would say it out loud. And taking a look at the results, we do indeed get the result that we were looking for. Hooray. And so hopefully it's clear like how much cleaner that code is. We don't need those exclamation marks. We don't need the extra logic. And dplyr, with filter out, dplyr assumes that if a row is NA or unknown, you probably don't want to drop it. And so it will only drop rows that definitively meet your criteria. Any questions about filter out? Yes, I agree. It is cute. It's very exciting. All right, but it's not just filter out that has been introduced. So when any and when all, these next functions are going to continue this kind of theme of intent-based coding, like what you do what you lead with exactly what it is that you want. So let's look at another example data frame. And so this one's called monthly losses filters. And so the issue that this is meant to address is that in older versions of dplyr, combining multiple or conditions and with this like long pipe symbol it's very easy to misplace where you're putting things. It's easy to misplace parentheses. The indentation gets super messy. And so we'll see how you can work smarter now. So let's say we want to keep rows where regions 7 or 8 have losses over 400,000 or where regions 2 or 9 have losses over 300,000. So take a brief look at this data set, try to think how which rows are the ones that we want to keep and how maybe you would write that using dplyr. Okay, in case you've taken a look, these are the ones that we want to keep. So again, in regions 7 or 8, over 400,000, 2 or 9, losses over 300,000. So 4 total. And so in this case, we can write something like this, which absolutely works. We get our result. But if you take a look at the code itself, I don't know about you, but it makes me feel like this. It's totally fun and it works, right? We get the right result. But as you can see, like it starts to indent. You have to remember, where you put your parentheses because there are a lot of them. As you can imagine, it can just get very unwieldy to write something like this, especially if you have many or statements that you need to write in a row. But we can use dplyr 1.2.0 and the new helper functions when any and when all. So rather than, again, trying to remember that logic and the pipes and the parentheses and everything like that, just know when any specifies any or conditions and when all specifies all conditions. And to see what that actually looks like, if you recall, we wanted to keep rows where when region is 7 or 8 and losses are over 400,000, regions are 2 and 9 and losses are over 300,000. So keeping that in mind, this is what it looks like now. And so here within our filter statement, we can use when any, and then those two statements that I just mentioned. And so it's hopefully an easier way of listing out your or conditions. Your requirements are just separated by a comma. Everything is indented, so everything's at the same level, and so hopefully much easier to follow. And say you get this to a colleague, hopefully easier for them to follow your logic. And so just to give a brief example of when any, when all, so remember all is for and conditions. So say we just want to filter or keep the rows where region is 7 and 8 and losses are greater than 400,000. We can also write it like this. So when all, and then your conditional statements within there. And again, hopefully like much easier to read and easier to understand. And the two examples that I gave here were filter examples. Remember, filter is to keep, but when all and when any also work perfectly with our new friend filter out. And so you can also say filter out when any of these specific uh, conditions are true, or filter out when all of these conditions are true as well. Yeah. I'm trying to upsell dplyr 1.2.0. I'll show how to upgrade at the end. I saw there's a question with tidyverse packages like dplyr, do we prefer the McRitter pipe, which if you've seen that before, it's a percentage greater than percentage, or do we prefer the base pipe? And that's the one that I'm using here. So there's a really good blog post on the Tidyverse blog about this, in case you want to take a look. But essentially, the idea is, for the most part, they are you can replace the McRitter pipe with the base R pipe pretty readily. I think for package developers, if you are working with the base pipe was introduced in 4.2. If you're using R 4.2 or above, it means that you can create your packages without having to require McGritter for your package, which, hope can make things more efficient. And then I would say, like in my pipelines, for the most part, I have pretty much replaced the McGritter pipe with the base R pipe in pretty much every instance. And then for the very small exceptions where the base hard pipe doesn't work, you can either, you can do whatever you want. You can switch between the two if you need, or there are also ways of writing your base R pipelines so that it continues to work even in those like particular cases. I would love to hear from the group whether they've made the switch or whether they're sticking with McGritter. But yeah, definitely wonder, Sona, I wonder which one you use as well. Okay, so we've covered filter out, when all, when any, but we're not done yet. Let's introduce the new recoding and replacing functions. And I couldn't help myself. I really wanted to show a real world example of my own journey from when I was first starting in R. And this was one of my most popular tweets back when I was still on Twitter. And what I had written was before I discovered case one. And so as you can see, it's a massive towering mountain of nested if-else statements. And so I was using BaseHard to hard code levels, subjects, and summary statistics into new columns in this data frame. It was enormous. It took forever to write. It was extremely error prone. One missing parentheses and the whole tower would fall and collapse. And so this process of recoding, which if you've ever done it before, it's saying if a column has a value X, the all other column should be Y. At least for me, it used to be a very stressful part of data cleaning. I learned about case one, which is, we mentioned it earlier, but it's a function within dplyr. So returning back to our original data set, I won't make us look at my whole data set. Case one was really helpful in kind of organizing those if-else statements. And so the way that it works is you typically use case one within a mutate function. You give it your new column a name, and then you list out all of your logical statements. And so in this example, what we're saying is when the region is one, I give it the name Yaren. When it's two, call it Reifilike. I'm sorry, I don't speak Norwegian, and so on. And as you notice, like it has this particular syntax, region equals one, tilde, and then what you want it to be coded as. And then there's also this on line 20, this default statement, which lets us guard against any errors. So we can say like for anything that doesn't match the conditions that we listed above, call it NA. You could also put other or something like that. So that way you can try and protect against anything that you may have forgotten. But taking a look at what this ends up looking like, now we have this data frame. And so we have species, geogroup, region remains, and then losses. But now we have this new column called production area, which was defined by my case one function based on the region column with the names of the different production areas. And this is not the only way. There are many, many ways of recoding functions. One example is with the function called recode. And so this might look really familiar. It looks very similar to, did I go back? Oops, sorry about that. The recode does look it looks so familiar. I mixed them up. Recode looks very familiar to case one, but as you can see here, instead of tilde, we just have a singular equal sign instead of, the region equals, and then the tilde and so on. But it works and it looks very similar. And so if we look at the output of this, it's the exact same output. So it gives me the same results, but done in slightly different ways. If you are a slightly more advanced R user, you might have used a package called rlang. And rlang allows you to do all sorts of fun things. For example, let's say that we create a lookup map using our list. So in this case, I'm creating a list called PO mapping, and within there are all those statements that I had within my recode function. One equals yarn and so on. And as you can imagine, this is only 13. But what if we had hundreds of regions, right? Like it would be so hard to put that within a recode statement. And what if you wanted to use it more than once and your script becomes huge and things like that? rlang is a package that allows you to use like the internals of your data frame and things like that, and to do all sorts of things. So for example, what recode does is, and with this triple bang operator, is it basically injects that entire list within your recode function to recode your data. And so if we output this, we get the exact same thing. And so I've just mentioned those, but all this to say, there are so many ways of recoding, if else, case one, recode with rlang. And each one of them is very specific in how it works. Each one of them, brings their own um, like set of syntax and everything like that. And it can get really confusing and things like that. But now I'm happy to say, as we see in dplyr 1.2.0, this process has been completely reimagined to be even more user-friendly. And so all those things I just talked about, you could just, forget about them, honestly. Really quickly, I do want to clarify two terms that sound very similar: recoding and replacement. So recoding is a transformation, like it's building a brand new column from scratch using an old one or multiple old ones as your guide. And each row in that new column is a result of your mapping rules. And replacement, on the other hand, is staying within the same column, but you're only updating specific rows. And the rest of your data stays exactly as it was. And now in dplyr 1.2.0, we have dedicated tools that are optimized for each one. So let's go back to a case one example. So if you see here, case one, I'm asking it to create a new loss rating column based on the losses column. If it's greater than 100,000, make it high. If it's less than 100,000, make it low. So taking a quick look at this, just take a few seconds. Would you call this a recoding or a replacement function? Feel free to add it in. Yeah, I saw some people wrote. You are correct. Because case one is creating a whole new column based on every value of another column, it is a recoding function. But now it is not alone. Now case one has a family. And so in the past, we may have forced our case one to work certain ways because we needed it to do a certain thing, even if it's not exactly what it was designed for. But in dplyr 1.2.0, case one now has three other functions that have joined it. So for recoding, we have case one and replace one. And sorry, for recoding, we have case one and recode values. I'm sorry. And then for replacement, we have replace one and replace values. And so you use the when functions, like case when and replace when you have logical statements like greater than 100,000 or less than 100,000 and so on. And then you use the values functions when you have a map like the one that we saw earlier. And a brief note, like I just alluded to, the recode function that we mentioned has been officially superseded by recode values. And if you've never heard the term superseded before, it's from the Tidyverse team. What it does is they have like different like life cycles for their functions. And so it's things like stable, deprecated. Superseded means that the function is not going away, so recode is not going to go away, but it's also not going to change. They're going to make sure that it still works, but nothing's going to be added to it. And the reason for that is there are better alternatives for you, in this case, recode values. So if you recall what we were doing earlier, our region region is a value. We'd like to recode our data set. We'd like a whole new column, right? Called production area. And so by grabbing those two steps, we know exactly which function we need. So again, recode, values, values. And as you can see, this code, it's very clean. We don't need logical equal statements or anything like that. We don't have to repeat region equals at all because we have piped it into the recode values function. And then we just map the old value or the thing that we're referencing with a tilde and then the new recoded name in this case. And as I mentioned earlier, like if case one or recode values, like they encounter a value that you didn't define, it usually assigns an NA or the default value. Before I also had default as NA, but you could put it as anything else. But there is this new argument that you could add called unmatched equals error, which is, I think, very nifty. So say I was unaware that my data set actually has 14 regions instead of 13. And so I didn't give it something to recode for region 14 to in in this pipe. I could put unmatched equals error. And when I run this, it will actually stop the code and it will let me know immediately, like, hey, you didn't match, your list didn't match everything that you wanted. And so that way I can go back and fix it, which I think is really nifty, especially if like, you don't want the things that you haven't mapped to be ENA or other or something like that. It's a good way of cleaning up your pipeline and avoid like those kind of like silent errors that could happen. But say I run this, we'll see. We have the exact same output as before, but hopefully like the process of getting here, I don't have to decide between all the various functions that exist and remember how to use them. All I could do is recode values. And then probably the thing I'm most excited about is, remember how I mentioned earlier, what if you have dozens, hundreds, thousands of regions, right? Like something completely unwieldy that you don't want to put inside a pipe statement. What you can do is reference a tibble, a separate tibble. So in this case, I've just taken that same list that I had used with rlang and the triple bang operator before and just created a tibble from it and called it, this is now my lookup table. So if you see here, the regions are in a from column and the names of the production areas are in a to column, right? And instead of having to write all this in, I can just reference it within my recode values function and say from and take all the rows from the from column in that lookup table and to take up all the rows in that to column from that lookup table. And that's what I can write. So if I need to add more regions, I could just add them to that lookup table. And running this gives me the exact same output as before. So even easier ways of recoding values. Just to briefly talk about replace values. So as I mentioned, recode creates a whole new column with all the rows. Replace values is staying within the same column and just changing certain rows of information. And so I don't want to create like a whole new column is what I'm trying to say. So in this case, when I was typing up the names of the production area, I realized I actually truncated a few of them. So instead of having to fix all of that with a case when or recode values or anything like that, I can use replace values. And I'm saying for this production area, change it to this name. And for this production area, change it to this name. And all the other values stay exactly the same. And so the output for this one, as we can see, production area now has the correct names for region 6 and 7. And I alluded to this a bit, but case 1 requires that default. Otherwise, it will default to an A. So in this case, what I'm saying is losses greater than 500,000, make it 500,000. For everything else, just keep the same value as before. So in this case, the only rows that have changed are 3 and 4, and the other ones stayed the same because they were less than 500,000. And so that's what default allows me to do, so that way it's not an NA. But since replace when knows that you're intending to only replace some of the values, that default argument is not necessary. It will assume any value that you don't mention is going to stay exactly the same. That's why you don't see a default here. So just to briefly wrap up a few things I want to mention. If you love case match like I have, it is now being phased out. If case match is another function from dplyr, and I think it was introduced in dplyr 1.0. It has been fully replaced by recode values and replace values. So my recommendation is to start making the switch in your code and things like that. Something that I'm sure could be a whole other Our Ladies Realm presentation is the speed changes that have changed with this new dplyr 1.2.0. So core functions like if else and case when have been completely rewritten in C and using the vectors framework. And because these are building blocks of the tidyverse, you're going to see speed improvements across almost every package you use that reference these functions. And then also, if you're a package maintainer or someone who works with lots and lots of data, hopefully, this is very exciting news. Something else I want to mention is, a lot of us work today using LLM assistants like Claude Code or Posit AI or things like that. And so the way that AI models work is generally they have a knowledge cutoff, for a certain date. And so because dplyr 1.2.0 is so new, it's very likely like it won't have knowledge of filter out or when any or the new recode functions and things like that. But you can upgrade your AI. There's a few different ways of doing it. Basically, before writing code, you could do something like give it the context, like I'm using dplyr 1.2.0, and then copy and paste the README from the release notes or something like that, or copy and paste the blog post from Davis that we mentioned earlier, things like that. And that way, hopefully you can write using the most updated version of the package. And finally, I also want to mention that dplyr 1.2.0 is a direct result of community feedback. So like the authors like Davis are incredibly active on platforms like Blue Sky, and they don't just post updates, they also ask for your thoughts. And so a lot of the functions that we talked about today started as these kind of open discussions. And in addition to social media, you can see ideas for the future of the Tidyverse in this TidyUps repo on GitHub. And this is where the Tidyverse team proposes ideas and invites others to comment. And so if you are wondering like why is it called recode values? Did they consider XYZ or something like that? I recommend, sorry, taking a look at the discussion and you can see, how like community members pitched in. And then also if you have your own ideas, you can also mention it there as well. And the authors really do look at how people are solving problems in the wild. So like this creative R-lang splicing that resulted in code values that I mentioned earlier. Livy here, and who works at Posit, was trying to figure out this solution for a fellow community member and posted about it. And Davis and the team saw it. And so the reason that dplyr is, you know, more efficient, faster, and everything is because the people building it are listening to the people using it. And so if you ever find yourself at a point where you have like a really messy workaround, I highly encourage you to share it, because you might just inspire the next big feature in 1.3.0. So just to quickly summarize, there is a new filter out function, which is a complement to filter. And then there are accompanying when any and when all helpers. And then also new recoding and replacing functions, recode values, replace values, and replace when, which are going to join case one as well. In terms of how to install it, you can upgrade today. My recommendation is using a package called pack, install pack, and then you can run pack dplyr, and then it will give you the latest version. And with that, thank you. Thank you so much for joining. I hope it was helpful.
Thank you very much, Isabella. That was great. If you have any questions, you can put in the chat or raise your hand in case you have any other questions.
I noticed the question about notice that true was replaced with default. True still works, but I believe it was in dplyr 1.1.0 that this new default argument was introduced. I think the idea was to know that like true was the default. Yeah, could be pretty confusing, and hopefully the default argument is a little bit easier to remember and to use. I believe that's the update that included it. And yeah, that's one I use now. I saw GP asked about labeled data. And so I believe like some of these changes might propagate into the forecats package for labeled data. But I have to admit, I don't use labeled data very much. So I would recommend looking up, I think it's Tidy Up 7 is about the recoding and replacement functions, and taking a look at the discussion there where they like have some examples and discussion, and feedback on labeled data. It's a great question about whether these will be compatible with big data packages that use dplyr syntax. I don't know. I will ask the team. I think that's a fantastic question. And I see the debate about the pipes as well.
Okay, well, thank you. I really like that tool that you presented, the modification of the data set with that tidy.
Yeah.
Yeah, so that is very useful as well.
Yeah. I think it's great. It's like you essentially give it the code and it will show you what happened to it.
Right.
And I know the examples I gave were single verb pipes, but it actually, like if you have multiple verbs in the pipe, it'll show you like each step and what happens and things like that.
Thank you very much to Isabella, and I guess I will host you again next year.
Awesome. Well, thank you. And an awesome job at everything that Our Lady's Room is doing. I'm always so amazed.
Great. So stay tuned because we'll have more tutorials as this one. So in the following months, and even the next event, the very next one is with Roma users group, where we will be talking about data visualizations. So stay tuned because I will post more about this next event. Thank you very much.
Thank you.
Please follow us on YouTube, and we will post the recording in there, also on our social network. Thank you very much.